Good morning. This is Matt Sexton with the Florida Department of Transportation's CAD office. Welcome to another installment of our webinar series on hot CAD topics. Today's topic is Project Primary Control Network Design Plans presented by Ron Hansen. This webinar will be recorded and posted to our webpage on the same page on which you registered for this webinar. If you have any questions, please enter them into the Q&A portion of the webinar dialogue. We will do our best to answer these questions in real time. All questions and their respective answers will be compiled into a Q&A document, which will be posted along with the recording of the webinar. If you experience any audio issues, the best way to fix that is to log out of the webinar and log back in, as we don't really have any control over individual audio settings. And now I will turn things over to Ron.
Good morning, everybody. My name is Ron Hansen. I'm with the Department of Transportation, Civil Integrated Management Unit, Surveying and Mapping Office. I am currently the Geodetic Services Supervisor, and we're going to talk today about network design plans. Some of the topics we're going to discuss today are the Surveying and Mapping Handbook requirements, completing a network design plan, planning sessions, and creating obstruction diagrams. So to begin with, we're going to go over the survey handbook and the requirements. In Appendix B, the GNSS guidelines. Section 2 is network design plan, and it goes over all the requirements that should be included in that will be included in every network design plan. To begin with is the project description, which should include the horizontal datum, vertical datum, and projection to be applied. And I have an example of a network design plan, and this is a sample project that we've worked on, but here is the project description. It's US Highway 90, Mahan Drive. The project limits are US Highway 90, 6,000 feet. Both sides of the intersection with Capitol Circle Northeast, City of Tallahassee, Leon County, Florida. The datum is North American datum of 83, adjustment of 2011. Vertical datum is North American vertical datum of 1988. The projection is the Florida State Plan Coordinate System, North Zone, U.S. Survey Foot, and the geoid is the Florida Permanent Reference Network 2018, or FPRN 18. So the next topic would be the type of GNSS surveying be proposed for the project. So we're going to be doing static GNSS, and basically we describe what's happening with the project. That is going to be static, and the vertical component will be of the static observations will be used to validate the level run that's been done. Describes the FPRN stations being used and that they will be held fixed constrained, and the session processing and the final adjustment. And then it describes all the PPC points. Now, keep in mind that this project, this sample network design plan does not agree with the project that I'm going to be demonstrating live. But it gives you an idea of what is required. Every static point must be observed a minimum of 2 times for a minimum of 15 minutes with 1 second epochs. separated by at least 1 hour. And in most cases with DOT, we have 3 receivers allotted to a crew. So we do 3 receivers. And in this case, there'll be more than 4 sessions on the live demonstration I'll be doing. Just some describes the what constellations will be used, and that we evaluate the data and discard any bad data based on multipath or cycle slips and so on, and any site obstructions. We described that it's going to be processed using Leica Infinity, and the least squares adjustment will be performed after incorporating level runs. Vertical control is all going to be based on level runs, utilizing a digital level. A digital level is a requirement for FDOT now. It describes the points being used, and then we can move on to the next section of the requirements. Oh, I'm sorry, the type of surveys, and then we're supposed to show a sketch. So that's further down. So this is the sketch of the project. And I use Google Earth to create the project sketches and all the pictures that you'll see. So there's the overall project. Then the next step would be identify the make, model, serial number of the equipment to be used. Which I did here. Just having a list of them, and then you can use these serial numbers further down in the session planning sheet. The next so the next step would be having a sketch showing the project limits with PPCs. So this would be the project limits showing the primary project control, which in this case was 5. In the live demo that I'm going to be showing you earlier for session planning, or later for session planning, there's roughly about 20 points or so. And then it moves on to secondary control, which we're not really covering in our network design plans right now. So we went over the sketch for the primary project control. The secondary project control, we're not, that's not being included right now in network design plans. And then we go into network design, which we show the overall network design in each session. So we show the overall network first, and then each session individually. So the overall network, you can see here, it shows all the FPRN stations on the outliers, and then shows the project in the middle. And then it gets broken down into individual sessions. It can be kind of hard to see here, but session 1 would be from this point 10,001 to 10,002 and 10,003, because there's 3 rovers being used, and then those tie back, the endpoints of those tie back to the FPRN stations. In session 2, I'm sorry, this is session 1. A little bit better, more visibility on that picture. And then moving to session 2 moves down to 3, 4, and 5, with the endpoints being tied to the FPRN station. So we'll go into how you would design a network. So this is a sample project that we're fixing to work on here in Tallahassee to do some product testing. And it's a fairly long project. We picked it to be long because of product testing. We needed it to cover all aspects. But so you can see externally, we have the 4 FPRN stations that would be used, which is FLJL, TALH, FLPY, and FLMD. Those will be the 4 stations used on this project. And we can begin going into starting designing our sessions. So since we're using 3 rovers, we would have baselines. And I'm going to start off with a bright yellow. So first session 1 would go here. I want to increase, and then you would have to tie those to the FPRN. So they'd be tied in there. And there. So that would be session 1. So what I like to do is, as I'm designing these, I like to keep a chart, and I've created a chart here that shows the different stations available in each session that we're going to have. I just went to 12. We probably will have more than that in this process. And then I start populating them with serial numbers. So I can go back here to my serial number list. I'm sorry, wrong page. So I have 3 different units that are being used. So I can use the last 4 is the easiest way. So 9715. $93.23. And the last one will be $89.80. So that's going to be session 1. Session 2 will pick up and basically repeat and it will start. So session 2 will not pick up on that point because you don't want to double occupy in two simultaneous sessions. So session 2 will pick up at this next point and go here. And then this endpoint here will tie back to the FPRN stations, and this point will tie to the other FPRN stations. Just a rule of thumb that your independent baselines, the number is your number of rovers or number of stations, I'm sorry, being observed, -1 equals your total independent vectors. In this case, we have 3 rovers and 4 FPRN stations for a total of 7. So 7 minus 1 is 6. And if you look with this, we will have 1, 2, 3, 4, and then the tie over to Madison will be 5, and the tie out to Perry will be 6. That's 6 independent baselines for that session. And that's how they all should be. So session 2, let me turn the labels on the points real quick. We'll start here at 1004, 1005, and then it'll go to 54, 23, 1001, which is what I have here. 1004, 1005, 1001. And basically you can keep repeating this session until you get this pattern until you get all the way to the end. So we can copy this and put it in session 3. Do that one in session 4, session 5, session 6, and then we start with some the last point is point 1013 in the schema or in the design plan. So that is the last point there, and then we have to go back and pick up the side, pick up the control that's not along the main corridor. So session 7, I'm not sure where it put my baselines. Which I have already drawn some of these. So session 7, well, I'm sorry. So we've went through all the main corridor and got almost all the vectors that need to be processed on that. The gaps, put them in the wrong folder. I'm sorry about this. Okay, so session 7 needs to incorporate these two points here, or session 7 and session 8 need to incorporate these 2 points. So what we're going to do is we're going to go from here to here and run that as one session there. With a tie back to the FPRNs, of course, on either end. And then the next one will be from this one. And we need to incorporate this 3 and 4 again. So the endpoints will tie back to the FPRN. And so session 7 would be from 1006 to 1003 to 1004. So session 7 be 9715, 9323, and 8980. I'm sorry, I did that wrong. 9323. So you go through this until every point has at least 2 observations, and completes every primary control point has at least 2 vectors running to it. So you can, when you come back through the next time, you can split them up, like after. So that would be session 7 and 8. I'm sorry, session 7, and then session 8 will be 1007 to 1003 to 1004. So you don't want to occupy the same point at the same time. So you could actually move session 8 to make it, call it session 9. So we would have and I tried to swap them out so they're not all occupying the same point at the same time, and try to keep the rovers not occupying the same point. Trying to keep a specific rover off of the same point as much as possible, so they will occupy, each will occupy the point separately. So for session 8, we can move down to the next intersection that's in this project, which is here. And I don't remember really how. Let's see. So we had session 1 would be here, session 2, session 3, session 4. So there's a gap on this side and a gap on this side. So for session 8, we could do something like this. Let's see if this, and then for session 10, see, we could do that. So 8 would go from 104 to 105 to 114. And session 10 would be 115 or 1015, 107, and 108. Sorry about that. I hit the wrong button. So you would make sure that you have at least 2 occupations per point for the sessions. All the points get observed, all the vectors get observed, and or all the baselines, saying that this is a baseline here, get at least 2 observations on it, and all the points have at least 2 observations. And you work that out with your spreadsheet here, so that everything, you make sure that everything has a double occupation and all the vectors have a double occupation, and you compile those into sessions. So after you get your chart done, and you'll go back and make sure that you do a session diagram for each session. So with Google Earth, if you group them, you can turn them off and on as you need them, but your session diagrams will look something like this. You could label them. You could label them as that this ties out to a FPRN station, and this one ties to an FPRN station, and so on and so forth, like we did on back on the other, back in the other path, the other sessions here, like session 1, where we showed the vectors going out to the FPRN stations. You could label those. Turn these off. So you can see that this would be session 1. You could zoom in kind of tight on it, create a map showing session 1, label this, label that, label this one, and label this one as that they're going to tie to the FPRN stations and what station it ties to. And then you'd move on to session 2 and show it. on an individual sketch. So session 2 will look like that, and so forth, until you have all the sessions done and they're all, you have sketches for every one of them and so on. The next part of that is to do an obstruction diagram. And I have opened Infinity to, well, let me pull this off to the side so I can get some information off of it while you'll see the Infinity screen. So for example, point number 1 that we had at the thing, at the beginning of the project, the coordinates on it, I've got them on the other screen here. But if you go to, and this is in Leica Infinity, if you go to processing and go to GNSS Manager, you can, you know what, I'm in the wrong screen. It's not processing, it's Coordinate System Manager. Forgive me, it is not Coordinate System Manager. It is where I said it was, GNSS Manager. And then you click on the Satellite Availability tab. When you can create a well, a new point here. Oh, I'm sorry, that's pulling up the reference stations. So we're going to create point number 5523C1001. It's going to receive all, you check until it receives all four constellations, because that's what we're doing on this. Give it a latitude and longitude. In this case, it's, sorry, I have problems with my fingers not working today. I'm sorry. Oh, I am sorry. This is giving me a fit this morning. Okay. Try this again. So to do it, you hit satellite availability, new site, and we're going to name it the point name, which is 5523C1001. Okay, so you create that, and you can go into predictions. Sorry. You right click on it, hit a new prediction, and it's going to ask you for the start date. So that would be the start date of your project. Let's just for giggles, let's say we're going to do this on starting on Monday, and we're going to run this obstruction. We're going to probably do all the occupations within 3 days. We're going to just do a rough 10-degree cutoff, and we're going to create this. I'm sorry, it wouldn't let me do 3 days. So okay. So it's going to give me a prediction. So this is going to show our satellite predictions for that particular site on those days. You can expand this. You can get more detailed on it by sliding it around. You can look at the satellite visibility chart. And if you have obstructions, which you can create obstructions on this, you can do obstructions on this. And for example, as we're looking at the site itself, and we're zoomed down into this, we can see that we're going to have some obstructions on the north side for tree cover and a little bit on the southwest. And for some reason, it's not doing an obstruction. And I'm sorry, this is giving me problems this morning, and it's not allowing me to create it, and I don't know why. It might be something with the licensing going on. But in Leica Infinity, this is where you would do an obstruction diagram. So basically, you'd have an obstruction coming across here, and then something down here in the southwest side. It'd be going along the north for the tree cover, and then along the southwest down here for the tree cover, and then each point would be different. And you create just an obstruction diagram. You do not have to create a prediction report, but just an obstruction diagram for each point. And I was hoping that would be a little bit smoother, but I'm sorry it was not, and my apologies. And I think that I'm sorry. And then final thing is that you have to include the data sheets that you're going to be using. So you're going to have, if you're using the FPRN, you can get those data sheets from our website. That website is right here. It's the FDOT.gov/geospatial/FPRN. And we have a link to our data sheets right here. You click on that link. It brings up all of our sites. One of the sites we were using was Perry. So FLPY. If you click on FLPY, it'll bring up the data sheet for Perry, along with all the superseded coordinates, and you save that and you submit that as part of your network design plan. If you're using any NGS points, you get their sites, you get their data from their webpage. And with that, that has pretty much covered all the network design plans. If I'm not mistaken about it, the sample network design plan is offered on our webpage, where you get all of our, you get the survey manual, and also where you get the feature codes. With that, I will let this go for questions. And I think I've addressed the one that's in the question screen right now, but if there's any other questions, please feel free to populate the question tab.
All right, so if y'all have any questions, feel free to go ahead and type them in. We will take a few more minutes to check out questions. Ron, thank you for the presentation. That was absolutely fantastic and educational. I learned quite a bit.
You're welcome.
Okay, it doesn't look like we're getting any additional questions in there. So just to remind everyone, we will have this recording of this presentation posted on our website, the same site where you registered for the webinar. That will be posted hopefully within the week. There may be some delay to that because we are going out of town for various and sundry conferences over the next week, but we'll go ahead and try to get that by the end of the week. So if y'all have any, oh, we got one. D5 has a PowerPoint created for obstruction report. Oh, yes. Okay, hang on. Do you want us to share? Yeah, if you want to send that to us, we'll incorporate that into the post on our website. You can send that to any one of us or to CADD.support.
10-4, and just a reminder, the obstruction report is usually filled out in the field. So as you're actually sitting up on where the point's going to be located, or roughly where the point's going to be located, you would complete the obstruction report in the field. And yes, there are blank obstruction reports, and we can incorporate what you have. We have some as well.
All right, excellent. Okay, without any further questions, we'll go ahead and end the webinar. Do appreciate everyone spending their morning with us. Thanks, and have a fantastic day.
Thank you.
Won't you ask me?